Okay, here's three good questions. First one's probably the toughest of all of them, and it requires an understanding of density that we haven't done, but I'll just show it to you quickly. On an exam, I won't ask you a density question. Okay, it says a nitric acid solution contains 71% nitric acid, okay, by mass. Then it says it has a density of 1.42 grams per milliliter. How many moles of nitric acid are present in 1.20 liters? So let's first figure out how much this total solution is going to weigh. And then we can figure out 71% of that has to be the nitric acid. Okay, so first off, density is a formula. It's equal to mass over volume. And again, this is a good point to make with the M's that you asked in your question. What do all these M's mean? And you have to sort of keep track of them. If you want to write it out and just write out mass over volume, you can do that just so you don't get mixed up. But typically a little m means mass, but also if you have a little m and a number in front of it, that m there means meters, right? Now capital M's another thing you have to worry about. Capital M can stand for a molar mass. If it's in a formula and I see capital M, I think molar mass. Some books have a capital M that means molarity too. So some books give you a formula, M is equal to N over V. So molarity is equal to the moles over the volume. I tried that for a while, but I typically, instead of saying molarity, I use concentration, a big C there. So C stands for concentration. M also, you could see something in a question that goes like this, 10.0 with a capital M, and that M there stands for molarity or moles per liter. So it is something that there's lots of M's. You just have to sort of be careful with which one you're using and where it is. Okay, in this question, I'm looking for mass because I know the density right there, and I know the volume right there. So if I manipulate that formula, mass is equal to density times volume. Density is 1.42 grams per milliliter times the volume, it's in liters. Maybe I'll change this to milliliters. I'd move my decimal 3 to the right, so it'd be 1,200 milliliters. Now the milliliters cancel, and I wind up with grams. So let's multiply that out. Calculator, 1.42 times 1,200. Okay, so that came out to 1,704 grams. So that's how much that whole container would weigh, is 1,704. And then they say 71% of that is nitric acid. So how much is that? Okay, so the formula for that is mass percent is equal to the mass of the solute divided by the total mass of the solution. Okay, so the total mass of the solution is this one. The mass percent is that one. So I can figure out the mass of the solute. So the mass of the solute is equal to the mass percent, which is 71%. Oh, I forgot to put a times 100 there. So the mass of the solute is equal to, maybe I should just rearrange that formula properly first. So it's mass of the solute, this is what I'm looking for, is equal to the mass percent, and then this has to go to that side, so it'll go on the top, times the mass total, and then the 100 goes to the other side, but it has to go on the bottom. So divided by 100. So the mass percent is 71.0 times the total mass is 1,704, divide 100. Calculator. So 71 times 1704, divide 100. 1209. So 1209.84 grams. That's how much the nitric acid would weigh. Oh, but then they say how many moles of that are there? Oh, okay. Okay, more to the question. So how many moles is that? So my formula here, I have a mass. The one formula I know about that one is moles is equal to mass over molar mass. So I'm looking for moles. I have my mass, it's right there. And now I need the molar mass of, what do we have? Nitric acid. So let's do that. So nitric acid. So I have one hydrogen at 101. I have one nitrogen at 1401. And then I have three oxygens at 16 each. So that'd be 48 total. So this would be, what's that? 63.02. So that's my molar mass. So my moles are going to be 1209.84, and I'm going to divide that by 63.02. Divide 63.02. So that comes out to 19.1977. I think I had to round to 3 sig figs, so I'd call it 19.2 moles of nitric acid. Let's see if that's one of the answers. Yep. Oops. Okay, here's another question. What mass of solute is contained in 65 mils, so that's a volume, of a 2 molar, in other words, 2.00 moles per liter, so that's a concentration, of sodium bromide solution. Sodium bromide, NaBr. Na is a plus, Br is a minus, so it's the same. Okay, so let's look at our formulas. I have this formula. I have this formula. They're looking for mass, so they want to know what that is. And I know what the molar mass, I could figure out the molar mass of sodium bromide, right? But I don't know moles. But here I have a concentration and I have a volume. So with those two, I could determine moles and then use that over in that question. So it looks like a 2-step question. Let's manipulate for moles. So I'll multiply both sides by volume. Moles are going to be equal to V times C. The volume, 0.0650 liters, times the concentration, 2.00 moles per liter. Liters cancel. And so, calculator, 0.065 times 2, 0.13. 0.13 moles. So that's how many moles of sodium bromide I have. Now I can use this other formula, and I want to manipulate it for mass. So mass will be equal to moles times the molar mass. Moles, 0.13 moles. The molar mass, oh, I haven't figured that out yet. Okay, so I have one sodium, weighs 22.99, and one bromine weighs, 79.90. 79.90. So I add these together, 12, 1, I think that's 102.89 grams per mole. So 0.13 times 102.89 grams per mole. The moles cancel. So I get that answer I just had, and I multiply that by 102.89. So that gives me 13.3757. And then I have to round that to 3 sig figs. So 13.4, and I'm looking at grams right there. Okay, well, let's. How many grams of calcium chloride? When they give you the mass. I wonder if that mass is correct. I'd like to check it. Because calcium is 40.08 and 2 chlorines are 7090. So if I add that, I get 110.98. I'm a little off. I'm going to use my number just because that's I like using this, being consistent with my periodic table. Okay, how many grams? So they're looking for mass, and they have a volume and they have a concentration. Oh, it's the same question as we just did. Maybe pause the video and see if you can follow it through the same as we just did, and then come take a look and see what you get. 2 formulas. I'm given a volume and a concentration, so I know these two. I can figure out moles. Moles are C times V. Concentration is 0.500 moles per liter times the volume, 3.03 liters. The liters cancel, so calculator, 0.5 times 3.03, 1.515 moles of calcium chloride. Now my other formula was moles is equal to mass over molar mass. Now I know what my moles are. I calculated my molar mass right here. So I have that. And so I can figure out what my mass is. So mass is moles times molar mass. The moles are 1.515 times the molar mass is 110.98 grams per mole. These cancel. And so I multiply. So the answer I just got times 110.98 equals 168.1347. 3 sig figs everywhere. So I'm calling that 168 grams. Let's see if they have that. Yeah. Probably didn't matter if I used 111 or this 110.98. All right, hopefully that helps you with those 3 questions.